So we're dealing with trig identities today. Hold on, let me let you in. All right. So what's the first? Do you have any problems up here yet? Am I the right one, Braden? Is this where you want me to be? Are you pasting them now? Can you hear me? You there, Braden? I can't hear you. Can you hear me?
Oh, can you hear me now?
Yeah, I got you now.
Yeah.
Okay.
It goes the other way. Like
What's that?
It goes the other way.
You put them at the beginning? Got it. Okay. All right, here we go. Trig identities. I'm just going to do these real quick, okay? And then when we're done, if whichever ones you need more help with, you just let me know. So to do these trig identities, you can do it in a couple ways. I like to just put the equal sign, keep the equal sign all the way down. And what I want at the end is I want this right side to be, or this right side right here to be the same as what this was. So
Yeah.
at some point, I'm going to end up with sine squared x minus sine to the fourth x. Okay,
Yeah.
So I just got to figure out how to get there. So the first thing I'm going to do is I'm going to rewrite each of these in terms of what they are. And remember, one of the properties that we have, I'll write over here, is sine squared plus cosine squared equals 1.
Yeah.
Means cosine squared equals 1 minus sine squared.
Mm-hmm.
Makes sense? So I'm going to rewrite this as 1 minus sine squared x minus, and now cosine to the fourth. I could think of that as, there's a couple ways I could do. Actually, you know what? I'm not going to do that first. The first thing I'm going to do is factor out a cosine squared. And that will leave me with 1 minus cosine squared x. See how I did that?
Wait, why would you? Oh, okay. Now I see what you're doing. All right.
Yeah, so I took a cosine squared out of each of those.
Yeah.
Now this, you'll notice that this just equals sine squared, right? Because if you look over to the right, I could have also written that sine squared equals 1 minus cosine squared.
Yeah.
So this thing here just equals sine squared of x. And this to the left equals 1 minus sine squared of x. And now if I distribute in the sine squared, what am I going to get?
Sine to the fourth.
I'm going to get sine squared minus sine to the fourth. So I only needed 3 steps for that one. All right, let's try the next one. Or the next couple. Let's see if I can sneak these.
Yeah.
Do all these ones? I'll just do them real quick. Okay.
Yeah.
Cotangent equals, let's see, that equals.
It's cosecant of x.
That equals cosine of x over sine of x.
Yeah.
Which I could rewrite this as cosine of x times 1 over sine of x. And what's 1 over sine of x?
Isn't that cosecant?
Yeah, and so I'm done.
Okay.
Got it. Now for this one, it would actually be probably easier if I start with the left side, not with the right side. So I'm going to keep this as 1, and I'm going to keep changing the left side. So the tangent is sine x over cosine of x. Cosecant is 1 over sine of x, right? And cosine of x is just cosine of x. Now this just equals, those all cancel out. The sines cancel out and the cosines cancel out, and you just get 1 equals 1.
Wait, where's the cosine at? The other cosine. Oh, I don't write. Oh, okay. I see.
Yeah,
what you
those canceled out, and then these canceled out. And
then
that's how
one
I,
equals one.
yeah. Same with this last one. The better thing to do is to start with this. And remember the properties we were talking about before, sine squared plus cosine squared equals 1.
Yeah.
So if I want the tangent one, I'm going to divide everything by sine squared. If I divide everything by sine squared, I get 1 plus cotangent squared of x equals cosecant squared of x.
Mhm.
And actually, that's not the one I wanted. I wanted to divide everything by, if I divide everything by cosine squared instead of sine squared, I will get tangent squared plus 1 equals secant squared. So this is just secant squared, right?
Oh.
So that's secant squared theta times cosine squared theta. And secant squared is just 1 over cosine squared. And those will cancel and you'll just get 1 equals 1. Got it?
Yep.
So for a problem like this, again, it's easier to start. See how the left side is just bigger? It's easier to change that side. The thing that you don't want to do is you don't want to change both sides. You can't work over the equal sign, meaning you can't change one side, on the first step and then change the other side on the next step. You can't do that. That's a no.
Right.
So you just have to stay on one side. Just keep one side constant. So we're going to keep this as secant, 2 secant of x. Whoops. Here, let me make this a little bigger. So we're going to keep this on the right side as 2 secant of x. And this is a little bit trickier. What I'm going to do is I'm going to multiply. This is kind of like a little trick that you kind of have to know. And that trick is to multiply this by 1 plus sine of x on the top and bottom. I'm getting common denominator.
Common denominator.
Yeah. Because when I do that, what's going to happen? This is one that you kind of have to watch me do first before you, like, I wouldn't expect a kid to know how to do this unless they've seen it done. And then on this one, you want to multiply this by cosine x over cosine x. And the reason is because when I multiply this together, what am I going to get?
Is it 1 or
I'm going to get 1 minus sine squared of x on the bottom.
Oh.
That middle term is going to cancel out. And the top is going to be cosine x times 1 plus sine of x. Just leave it like that. Don't distribute it. Yeah. And then on this other one, I'm going to get 1 minus sine of x, cosine of x, all over cosine squared of x. And remember that one, I'm hoping that equals 2 secant of x. So now this equals cosine squared of x. So I have cosine, and I'm going to go ahead and distribute these in now. So cosine of x plus cosine x sine x all over cosine squared of x plus cosine of x minus cosine x sine x all over cosine x equal 2 secant x. Do you see how I did that?
Yeah.
Now, since I have common denominators, I can combine them together. So cosine x plus cosine x sine x plus cosine x minus cosine x sine x all over cosine squared of x. And I'm hoping that equals 2 secant of x. And sure enough, what happens? These cancel. And I end up with 2 cosine of x all over cosine of x equals 2 secant of x. And then cosine x squared on the bottom. And one of those cosines canceled. So I get 2 over cosine of x equals 2 secant x. And this is 2 secant x. And I'm done.
Okay.
Again, go back and watch that again later.
Yeah.
That was the trickiest one so far. So for this one, we probably could work on the right side. Let's see if we can work on the right side. If I work on the right side, this is going to be 1 over sine of x minus sine of x. And that equals, now I'm kind of looking over here and thinking, well, I want sine and cosecant on the bottom. So, so you can just get that common denominator if you want. You can multiply this first one by cosecant x on the top and bottom. Sine x cosecant x minus, now let's get that in the bottom of sine of x. So that would be sine squared x cosecant x, because I'm multiplying it the top and bottom by this essentially.
Yeah.
All over sine. I'm doing that just because that's what I want to be on the bottom.
So you can get like common denominators.
Yep, common. Yep, exactly. I'm getting common denominators. And now I'm gonna, since I have common denominators, I can put them together on the top. 1 minus sine squared x cosecant x all over sine x cosecant x. And this equals, now I can factor out a cosecant x, and a 1 minus sine squared x would be left over, all over sine x cosecant x. And then 1 minus sine squared x is cosine x. Or sorry, cosine squared of x. I think of why this is not working out for us very nicely here. First of all, did I do everything right? Multiplied by cosecant x here, and I got it on the bottom, multiplied by sine x and cosecant x on the top and the bottom, got that there, factored out a cosecant x. Oh, it's not sine squared, it's, oh yeah, it is sine squared. And so sine squared, 1 minus sine squared is cosine squared. I'm just trying to think of how I can do that in a different way. Because now the numerator is not the same thing as what it is on the left side. So I have to do some more. Oh, well, hold on. I could have actually taken this. Let's clean this up a little bit. I could have, instead of that, I could have canceled out. Yeah, that's what I could do. Secant or cosecant of x is 1 over sine of x, right? So what I could have done instead is rewritten cosecant as 1 over sine. Now one of those is going to cancel, and now I will have what I want. Cosecant x minus sine of x all over sine of x cosecant x. Okay. Make sense?
Yeah. They're just kind of.
Yeah, the trick for you is going to be when you see a problem, knowing where to go, what direction to go. And sometimes you don't know, right?
Yeah.
Sometimes you look at it, you're like, shoot, I don't know. I'm not sure how to do this. And so you just try something. If it doesn't work, try something else. Let me show you what I mean by that. I'm going to take that same problem now, and I'm going to do it a different way. So let's say that I wanted to start on the left instead of on the right. I'm going to keep changing the left side. So the left side would equal, I could try it like this: cosecant x minus sine x all over sine x times 1 over sine of x. Oh man, that would have been way easier. And then that, what happens to the sine of x? That cancels out, right? So you just get cosecant x minus sine x over 1.
Doesn't the one on top have to cancel, or do you not have to cancel it?
No, there's no, because this right here, no, that just means that you have a 1 in the bottom, which is just the same as cosecant x minus sine x. You don't have to write the 1 in the bottom.
Okay.
So it actually would have been easier if I started on the left side.
So, okay. Like when you're doing one of these problems, so there's like the Pythagorean identities, and then so like, can you do a problem without using a certain identity? If like I only wanted to use the
definitions of yeah. Sometimes you just use definition of what a sine and a cosine is. Sometimes you just use algebra. Yeah, but it's good to know the identities because they come in handy. So the Pythagorean identity is a big one. And there's a bunch more identities that you can find too. But when you're doing these are like the more basic ones. Mm-hmm. You're kind of at the beginning of this. If you're doing more complicated ones, then you would use like the double angle identities and half angle identities and sum difference identities. There's all kinds of identities. If you go to Google and you type in trig identities, you'll see like a worksheet or like a formula sheet with tons of them. Okay. Like for instance, this is now an identity. If you really feel like that's useful to know, you could create, this is called Braden's identity. Oh, this equals this. Now, no one would want to do that because when are you ever going to use that, right? Yeah. But in theory, if you prove this, then you can use this from now on. Whenever you see this, you could substitute this in for it instead because you've proven this identity to be true. Okay. This is called Braden's second identity. If you wanted to be so, okay, daring to claim it as your own, no one would ever publish it because no one would ever want to use it. Because when are you ever going to want to turn 2 secant of x into this? If you ever did want to do it, all you're doing is simplifying it, right? All you really have to do is take this and say, hey, can I write this in a simpler way? And as you go, you'll be like, oh, look how simple I could write that. Instead of writing this big mess, I can just write 2 secant x. All right. Okay. And also there's, if you go to my web page, 204 Tutor, you'll see a bunch more. Okay. I'll show you real quick how to get there in case you don't remember. If you go to 204tutor.com and you go to more videos and Trig, right here on the right, you see Trig. There's one called Basic Trig Identities and Verifying Trig Identities. Okay. So you probably want the Verifying Trig Identities. You go there and you'll see a bunch of examples. So feel free to grab that, and as you're going through it, that might even be some of the same ones that you have. Oh yeah. Okay. Okay. All right.
Research shows nostalgia can help you remember apps.
Nice talking to you again. Good luck with this.